Okay, students, so this is page 100 of the notes where we're going to talk about paired data or dependent samples. Now in this situation, what I like to often think of to help me remember what to do is I think of before and after studies. Because in dependent samples, it's important to note that we obtain a simple random sample of n matched data pairs A and B. Let D be the random variable representing the difference between the values in the matched data pair. So the important thing is that it's a matched data pair. So when I think of matched data pairs or dependent samples, I think of before and after studies because you have the patient before you administer the drug or experiment, and then you see the results afterwards, and it's the same patient. Okay? So what we do is we compute a sample mean for the differences, d bar, and a sample standard deviation, again for the differences. So if you know the differences are distributed normally, which if the sample is distributed normally, then any sample size will do. Otherwise, we're going to need a sample of n greater than or equal to 30. In these examples that we're doing, we usually assume that we have a normal distribution taking place. Hypothesis, we always want to see if the mean difference is greater than 0 or less than 0. So our hypothesis is always going to be set up mu d equals 0 versus the alternative that it's greater than 0, or mu d equals 0 versus the alternative that it's less than 0. If you're doing critical value method, you're going to need a t critical value with degrees of freedom n minus 1, a test statistic with t equals d bar minus 0 over the standard deviation of the differences divided by the square root of n. And then you have your decision and your conclusion. With a p-value, what you're going to use is a simple t-test, however you'll be using the differences, which we're going to do. So this is page 101 of the notes, and I'm going to do this in two separate videos. I'll do the p-value method, and then I'll do the critical value method. So this is the CV method here. Okay? But no matter which method you do, you have to calculate the differences. So this is the patient number 1, had a score of 121 before counseling, and after counseling had a score of 76. And this is anxiety scores. So we're trying to see, does counseling help reduce anxiety? So the first step you have to do is calculate the differences. So take the before and subtract the after. So 121 minus 76 gives you 45. 93 minus 93 gives you 0. And keep going down the list. You should be getting 41, negative 2, 48, 18, 63, 51, 36. Okay? And then your next thing that you have to do is you have to calculate d bar and the standard deviation of the differences. So if you're doing this by hand, remember your average formula, the sum of the x's divided by n, and then remember your standard deviation formula. Or your calculator can do all of this for you using 1 bar stats. You should be getting 33.33 for your average of the differences, and your standard deviation is 22.92. Okay? Now, I'm going to split what I'm going to do next into two separate videos, so it depends on what method you have become accustomed to using. If you're accustomed to using the critical value method, watch that video. If you're accustomed to using the p-value method, watch that video. Okay? Stay tuned for that.